Jungle.
Okay, firstly, strategy to perform material selection with defined function. Car bumper with defined function. First point is car bumper must flexible enough to reduce passenger injury. Second point is car bumper should be impact resistant to absorb minor collision without permanent damage. And last point is car bumper stiff enough to dissipate kinetic energy in high speed. Material selection strategy to choose best material for car bumper. Firstly, we must translate the design requirement that car bumper need, which is function, constraint, objective, and free variable. Next, we must screen the material using the constraint. We need to eliminate the material that cannot do the job. Next, we rank the material using objective. And lastly, we seek recommendation for the material. After we done all this process, we can choose our best final material. For the design requirement, firstly is function. Function is car bumper. Next, constraint. The constraint for this material must be high volume manufacturing, easy to manufacture, lightweight, high strength material, and low cost. The objective for this car bumper is to minimize cost and minimize weight. The free variable is choice of material and choice of process. For list of material for car bumper, after we considering the material selection strategy, we found that the best material is in polymer family, which is the firstly is explosives, second polyester, third polyethylene, fourth polyamide, fifth PEK, sixth PET, and lastly POM. Material. After considering all the constraints and done ranking process, we choose polyamide as our most suitable material that meet all the criteria that we need for car bumper manufacturing.
Hello, this is Sim Yu and I would like to talk about manufacturing process for car bumper. Manufacturing process for car bumper. In the current company, there are two processes is involved. One is injection molding. The second one is called blow molding. Injection molding is a manufacturing process for producing parts from both thermoplastic and thermosetting plastic materials. Okay, from here we can see that injection molding is very suitable for plastic materials. Next, material is fed into a heated barrel, mixed, and forced into a mold cavity where it cools and hardens to the configuration of the cavity. This point right here, it means that the material will be heated right here and mixed and forced into a mold cavity where it cools and hardens into the configuration of the cavity. The injection molding process requires the use of an injection molding machine, raw plastic material, for example granular or powder form, and lastly dye. How it happens for injection molding? The plastic is melted in the injection molding machine and then injected into the mold where it cools and solidifies into the part. Okay, to further explain this point, we'll move on to the next slide. This animation right here, you can see that at first clamping involved, and then it will inject the material and cooling process happen, and at last it eject the product. This is a video of injection molding for car bumper. This is the injection molding machine. The injection molding process happens inside the machine. Now it ejects out, and you can see that this black color right here is the car bumper itself. the worker will manually take out the car bumper. And you can see this right here, this steel is the mold of the car bumper. Next, we will talk about blow molding process is also called as blow forming. It's a manufacturing process by which hollow plastic parts are formed. The blow molding process begins with melting down the plastic and forming it into a parison or preform. A parison is this blue color right here. The parison is a tube-like piece of plastic with a hole in one end in which compressed air can pass through. So you can see in this figure the parison right here, and there's a hole at the end so that the air can be passed through. The parison is then clamped into a mold and air is pumped into it. The air pressure then pushes the plastic out to match the mold. Once the plastic has cooled and hardened, the mold opens up and the part is ejected. This is an animation of the extrusion blow molding. The parison is being put into here and the air will be pumped into the parison. This is an example of blow molding process for car bumper. This is the parison, and then it will be clamped together, the mold, and then the air will be passed through it. And then once it finished mold, it will be cooled down, also same as injection molding, cool down to make the material harden, and at last it eject out.
Step of the production process. Our group decided to choose resin transfer molding as the process to be further explained. As you could see here, down below this is the illustration of the resin transfer molding process, and as you can see here, there is a mixing head, a vent, a fiberglass, and mold. So for the next slide, I will explain the detail of the step in the resin transfer molding process. Okay. For the first step, is called creating the preform. The preform or contoured fiberglass reinforcement is the matrix that already in the shape of finished product, into which the resin will be injected. First, the type of fiber must be defined. For the second step, it is called preform layout. Once the preform or fiberglass reinforcement is created, it is packed into a mold cavity that has the shape of desired part. And the mold cavity is then closed and clamped. The mold cavity allows for a precise control over part thickness and allows for a smooth finish. Gel coats may be used inside the mold to provide a high quality, durable finishing. For the fourth step, it is called injection phase. A catalyzed low viscosity resin is then pumped into the heated mold under pressure, displacing the air through vents until the mold is filled. So this phase must guarantee the complete impregnation of the preform. Curing phase is the last step for this resin transfer molding process. So the resin will be allowed to polymerize to become a rigid plastic, but the curing time varies and it is dependent on the mold temperature and chemistry of the resin that is being used. So below is the illustration for the steps in the resin transfer molding process.
Manufacture of car bumper with a considerably greater degree of accuracy and manufacturing process control. Precision and accuracy of resin transfer molding. High tolerance dimensional capability with matched metal tooling. Accurate adjustment of catalyst ratio ensures the parts cure at desired rate. The pressing tools were created with utmost precision to ensure the precise shape. Produce uniform part thickness based on the mold cavity. Important parameters. The RTM process is governed by variables and parameters that are dependent on each other. Their combinations affect the process and the quality of the finished product. Consequently, they need to be carefully determined. The important parameters, which cannot be neglected in the designs, are pressure, temperature, viscosity, permeability, volume fractions, and filling time of process. Manufacturing process control. Manufacturing is all about process improvement and quality control. Flow front reconstruction. Flow front reconstruction. One can construct 3 imaginary paths for resin flow from the 3 injection ports at one end of the mold. toward real-time estimation of flow front. It is necessary to know the flow front location in order to perform feedback control on the flow front progression. Flow front control. The result of flow front control experiments by zone temperature control of the mold and by feed rate control as presented in this section.
Today, I would like to talk about develop a manufacturing process selection strategy. Let's take a look at what is manufacturing process selection strategies for a car bumper. At first, identify all the processes. Next, translate design requirements. Next, screen using constraints. Then, rank using objective. After that, seek supporting information. Lastly, finalize the process choice. Translating design. The design requirements that obtained after translating the case study is function, car bumper, constraint, material that used is glass reinforced polyester, mass 4 to 10 kg, section thickness 5 mm, shape 3D solid shape, batch size 100,000. The objective will be minimize production cost. Fixed variable will be choice of process and process chain of. Let's identify the suitable process that can be used to manufacture a car bumper. Let's take a look at first chart, which is the process material chart. From this, we can identify that the process that's suitable for a car bumper using a polymer based material is conventional machining, injection molding, rotational molding, polymer casting, and also resin transfer molding. The process shape chart. Since our car bumper is 3D solid, the suitable processes will be sand casting, die casting, investment casting, low pressure casting, forging, powder methods, electromachining, conventional machining, injection molding, compression molding, polymer casting, resin transfer molding, and lastly layup methods. The third chart will be the process mass range chart. As we can see, the mass that required for the car bumper is 4 to 10 kg. The suitable processes that can be used to manufacture car bumper will be conventional machining, injection molding, compression molding, rotational molding, thermoforming, polymer casting, resin transfer molding. Next, the process section thickness chart. As we can see, the process section thickness chart, the suitable processes that can be used for a car bumper will be conventional machining, injection molding, compression molding, rotational molding, thermoforming, and also resin transfer molding. Lastly, the process economic batch size chart. The processes that involve for this chart, based on this chart, will be injection molding, blow molding, compression molding, and also resin transfer molding. Let's screen this using the After screening this based on the constraint, we obtain 3 best processes such as injection molding, compression molding, and also resin transfer molding. Let's take a look at what is injection molding. Injection molding is a manufacturing process for producing parts from both thermosets and thermoplastics. Injection molding is commonly utilized in mass production and prototyping and fairly new way to produce components. The second process, compression molding. Compression molding is widely used molding processes for thermosetting plastics. Compression molding is a high volume, high pressure method suitable for molding complex, high strength fiberglass reinforcements. Lastly, resin transfer molding. Resin transfer molding is also known as RTM, which is a method for the production of component parts made of fiberplastic composites. It has high fiber volume laminates, can be obtained with very low void contents. It's also able to reduce ranking based on objective. After considering all the constraints, we use process selection strategy to the most suitable process for car bumper. After we done screening based on constraint, we found out that 3 best process, which is injection molding, compression molding and resin transfer molding. Each process have their pros and cons for making car bumper, so we need to rank them based on the objective so that we can finally finalize the best process to manufacture the car bumper. As we can see, injection molding, the production cost is moderate. Compression molding, the production cost is high, while the resin transfer molding, the production cost is very low. Finally, finalize the final process for car bumper, which is resin transfer process. The resin transfer molding, which is RTM, is the best process to manufacture a car bumper based on the constraints and objective that we obtain. This is how the resin transfer molding take place.